Okay, let's go over the basics of electrolytes, starting with potassium. Potassium can be estimated based on the gender and the amount of wasting the patient has. Most clinicians will use about 50 millimoles per kilogram for a typical male. Total body water can be estimated for a male at 60% and for females at 50 to 55%. So given the example of a 70 kilogram male, you multiply that by 60% and you get 42 liters, 35 liters in females. Looking visually how this is broken up, you have the intracellular compartment and also the extracellular compartment. The extracellular is further broken down to the vascular and interstitial at a ratio of 25 to 75%. Total potassium, as I mentioned earlier, is about 50 milliequivalents per kilogram. Now in this case, millimoles and milliequivalents are about 1 to 1. This gradient of potassium is generated by the sodium-potassium ATPase at 2 potassium being pumped in with 3 sodiums being pumped out. This leads to potassium being a major cation in the intracellular compartment. 98% of the potassium is actually intracellular with only 2% extracellular. So doing the math of the 70 kilogram male, multiplying by 50 milliequivalents, you get 3,500 milliequivalents total. 90% of that would give you 3,430 milliequivalents in the intracellular compartment, with 70 milliequivalents left over for the extracellular compartment. Breaking on the ratio of 25 to 75%, you get 17.5 milliequivalents and 52.5 milliequivalents respectively. Looking at total body water, 2/3 of the body water is in the intracellular space, 1/3 of which is in the extracellular. Again, this is a ratio of 25 to 75%. Earlier, I gave you an example that was 42 liters. 2/3 of that is in the intracellular with 14 liters in the extracellular. If you break that down further, 3.5 liters in the vascular and 11.5 liters in the interstitial. Now, if you look at the amount of potassium that's actually in the vascular space, this only represents 0.5% of the total. Yet, when they're doing blood draws, this is the potassium that they're actually drawing, and this is the potassium that's actually present in the blood vessels. If you were to divide 17.5 milliequivalents by 3.5 liters, you get 5 milliequivalents per liter, which also happens to be within the normal ranges of potassium of 3.5 to 5 milliequivalents per liter. I hope you find this information useful. If you would like to see more, please subscribe to my channel.